Good morning, sir.
Yeah, good morning, sir. My voice is
Okay.
audible, right?
Uh, shall start, sir.
Yeah,
Okay.
yeah. Okay. Shall I start?
A very good, a very good morning to one and all, and warm greetings to one and all present here. It's my pleasant duty to propose a gracious welcome to you all for this generic talk series on intelligent robotic automation, design and control of autonomous systems. At this juncture, I'd like to thank a management, a vice chancellor, a principal, Dean Research Sir and Dean Academic Sir and our HOD. I'll take this opportunity to express a special welcome to all our Vice Chancellors and Principal Sir, Dean Research Sir and Dean Academic Sir and Department of HOD Department of Artificial Intelligence and Data Science. I'd like to welcome uh, all the parents, faculty members of various departments and ADS department, and all the students for this generic talk series. I like to elevated to see excited participants who are connected through our channel. I'd like to welcome today's guest, uh, Mr. N. Gopinath sir, for who is a guest of this generic talk series. Now I'd like to introduce today's guest, Mr. N. Gopinath sir. He
Yeah,
is a 15 years experience in design and engineering of tanks and vessels, industrial dampers, centrifugal fans, conveyors, and static equipment for various industries, that is thermal power plants, cement plants, steel plants, and oil and gas, etc. He is currently a senior engineer, design and engineering, HOWDEN Air and Gas, India Private Limited, Chennai. His roles and responsibilities are responsible for design and engineering of tanks, vessels, and centrifugal fans. He also has the responsibility of team management, where allocation of work, strategic approach, optimistic time reduction. Also, he is training provided for team members, approving technical documents, fabrication drawings. He coordinates with the production department to resolve the design-based manufacturing issues. Also, he coordinates with customers for technical clarifications and site queries of erection and commissioning. He verifies welding procedures, material specifications, other technical data. Visits customer sites for verifying and resolving the equipment operational problems. I welcome you, sir. Now the time is yours.
yes. Good morning to all. Uh, Thanks for this great opportunity to be presented to sharing my knowledge to the people who are all participants in the students and parents and other teachers. I'm welcoming you all. And today's topic is intelligent robotic automation and design and control of autonomous system. Uh, and I'll introduce myself. I'm N. Gopinath. I completed M.Tech in machine design. I'm presently working in HOWDEN Air and Gas India Private Limited, who are handling design and engineering manufacturing process in the organization. Okay. Today we will just review about the content is industrial revolutions to next gen, industrial application of automation systems, human intelligence, how it comparable with artificial intelligence, and how we are using a manual welding like process and robotic welding system, methods for programming robotic welding. So then automation and design control by using 3D scanning technology and virtual reality, and the other one is augmented reality. This is the industrial revolution. How the industries are revolution from 18th century till date. So initially it was in industry 1.0. In during that time, the mechanization and water and steam powers are established It was established to start in that 18th century. It means steam power plants and steam power based power plants and coal based power plants, other water resources sectors. It was established during that 18th century. The next stage is Industry 2.0. It was innovated and new things are established in the 19th centuries. Mass production. Basically, mass production for our case, one of the example you can consider in automobile industry. Maybe they are manufacturing as a car manufacturers or motorbike manufacturing. We will call it as a mass production area. So over that kind of industry was boomed at the 19th century, and the electric power sectors and assembly line. Assembly line means it's a continuous manufacturing system. If you anybody have that exposure to visit that automobile manufacturing industry, like manufacturers of cars and manufacturers of trucks, manufacturing of bus, they are having an assembly line. It's a chain type of assembly. They initially it is one part is manufacturing and multiple parts is getting into the conveyor line. Then each and sub assembly, each and sub assemblies are assembled in the one say third stage, and fourth stage should be the complete assembly. And final stage is the painting area. Like the multiple segment it is happening during the assembly line. Industry 3.0 is automated computers, automated and production and electronics in the year of 2000. Then Industry 4.0 is cyber physical system and IoT, networking, machine learning. This in Industry 4.0 was established and innovated in the 2010. From the 2010, we are using this kind of technology. Then now we are in Industry 5.0. Then it is a human, how we can collaborate with humans and robot, how we can able to work together effectively, and how we can able to improve the productivity and maintain the quality of the product to the reach to the goal. And cognitive system customization. So little brief. So here is a detailed breakdown of industrial version and transformation, how it is transformed from 1.0 to 5.0. In the 18th century, introduction of mechanical production powered by water and steam, this era saw the rise of textile mills, metalworking, and coal mining industries are developed and increased over there. Industry 2.0, it is starting 19th century. This revolution introduced mass production technique just before I explained by the technical electricity and assembly lines. Then Industry 3.0, this phase emerging around in the 2000s year, now 2000, focused on automation through the computers and electronic system. It is also a beginning of globalization with offshores of production to lower cost economic. So this is technology we are following in the Industry 3.0. And Industry 4.0 is characteristics of Internet of Things, IoT, how we are using internet, how that internet helps us to develop the manufacturing system. And then one is artificial intelligence and big data analytics. Data analytics is a more important role playing in the organization. So each and data analytics means each and every task we have to make a data. In that data we have to analyze whether how we are growing, how we are where we are lagging, and what is the corrective action need to be done, how we need to improve the process. For that kind of approach, data analytics is more useful for us. This is the industrial 4.0 enables real time monitoring, data driven decision making, and enhanced automation. It means we can identify the real time monitor the system. So then and there we can able to identify the errors, and we can able to solve the error immediately um, with the technology of using AI or other kind of technology in Industry 4.0. Then Industry 5.0 starting around 2020, the latest stage is Industry 5.0. The focus is on human machine collaboration, personalized production, and increased sustainability through resource efficient process. It aims to leverage human creativity and skills alongside advanced technology. It means how we can able to operate the robot. Each and every robot was designed and manufactured by the humans only. Humans only. All the programs, how that robot system need to be work, how they able to deliver the product, how much speed they can able to work, and which direction they can able to move. Everything which is decided by the humans. After the humans only, the robot can able to work. An industrial application of automation system, where what other industries are using the automatic system. It means automobile systems, automobile industry, aerospace industries, cement industries, power plant, cement plant, oil and gas, chemical, agriculture, defense, shipbuilding, robotic, and motor and pumps. So wherever the manufacturing segment or process segment is there, in each and every industries have the automation system in various s- various driven. So we will see here in this topic only minimum kind of automation technology, but there is a lacks of technology is there in automation system. In future we have to adopt with the technology only. First I will explain about the intelligence, human intelligence. So human intelligence, what it is: creativity and innovation. Humans possess the unique ability to generate novel ideas and concepts and solutions. The emotional intelligence. Humans can understand and respond to emotions. Robot cannot able to respond the emotions what we have, both their own and those of others, which is crucial for social interaction and empathy. Adaptability and flexibility. Humans can readily adapt to new situations, learn from experience, and apply their knowledge in diverse context. It is different from the robot, artificial intelligence. Then ethical resourcing, reasoning, and decision making. Humans can make complex decisions based on a range of factors, including ethical and moral considerations. This is a artificial intelligence. What is the difference between human intelligence and artificial intelligence? We are seeing just before human intelligence, what are the things need we can able to consider, and it is possibility to act. Here are the artificial intelligence. Artificial intelligence, by using the technology, you can increase the speed and efficiency. AI can process information and perform calculations at significantly faster speeds than human, because the speed and efficiency, the calculation process, everything, it was one time feeding into the artificial intelligence. Then later on they will continue with the process. Data processing. AI excels at analyzing vast amounts of data to identify patterns and make predictions. So he can able to identify the data, huge data, in fraction of time, in short period. So compare than human, we cannot able to analyze the data. It's huge data in short period, but in the artificial intelligence they can able to analyze the data. But even all the information we have to provide into the AI, later that only they can able to act accordingly. Then repetitive task. AI can automate and efficiently execute repetitive tasks that humans might find tedious or error prone. There is a may chance humans can make a mistake by unknowingly or unfortunately, but once we programmed with the AI with a perfect system, they can able to continue the work regularly without any kind of error, because he cannot able to deviate the program with our knowledge. So we, if we need to change any kind of work to the AI, we need to reform the programs. Specific skills. AI can be trained to perform especially well in specific tasks such as image recognition or playing complex example. These are just for an example. Image recognition and playing complex games. We have to train means we have to program continuously. We cannot able to train directly, and we have to train them through the programs and other kind of technology. We have to using the sensors. The sensors is playing a major role in the artificial intelligence systems. So now I will take just few example comparable with the robotic welding and manual welding, how the technology evolving nowadays by using robotic welding, how we you are using manual welding. Even still we are using the manual welding also. Some criteria we are using manual welding, some other criteria we are using robotic welding. For example, if we are manufacturing a mass production component or fabricated equipment in the same size or similar changes on the sizes, we can go with the robotic welding during the mass production system. And the manual welding wherever we can use it means it's a irregular profile, it is a complicated things. A robot cannot able to move each and every places whenever they want, but humans not like that. Humans can able to move whenever they want, wherever it is required. Even though the space constraints also, they can able to manage to weld the part, steel part. Just I will a few things I would like to share. Flexible welding. Manual welding, it's flexibility and adaptability. Skilled welders can easily adapt to the changes. Geometry means dimension. For example, if we able to weld 100 millimeter of length, but human can able to change based on the practicality. They can able to change that 150 mm or 50 mm. They can able to increase the length distance of the welding, maybe 150 mm or 50 mm, based on the criticality, or if he found any error during that time. But robot cannot able to change the immediately. We until we have not yet programmed. If we program, they can able to do it, but we cannot expect the error wherever it is applicable. And materials without the need for extensive programming. Lower initial investment. Setting up manual welding equipment generally requires a smaller upfront investment compared to robotic system. For example, if we need to install or purchase a robot, we have to import the material and we have to get the supplier, and we need some training to operate the robot. We cannot able to directly operate the robot. For that, we need a to training for the to operation of the robot. Suitability for specific task. Manual welding excels in task requiring intricate detail. Welding is confined spaces or on parts with regular shapes. Just before I explain, in irregular shapes also human can able to welded over there, but if compare them robot. Problem detection. Human welders can detect and react to unforeseen issues or changes during the welding process. If human identified the error, he can able to rectify the errors during the process. That is a advantage of manual welding. The below images just I shown. Flexibility, cost reduction. Cost reduction means in terms of investment, initial investment. Then it is problem detection. The human can able to detect the problem during the process. The next one is robotic welding. The robotic welding is precision and consistency. Robotic welding system offers high repeatability and maintain precise control over welding parameters, leading to reduced effects. So robot can able to weld repeated job continuously with high speed and maintain the precise control. It means robotic precision is more than the human. And increased productivity and efficiency. Robots can operate continuously without breaks or fatigue and production speed, especially for repetitive task and high volume production. But robot can able to operate 24/7, but human cannot able to work continuously because he needs some. Is a human actually. He needs some rest. He need a tea break. He need to go home. He needs some personal work. So he cannot able to continuously through the day. So a replacement of human, we can able to use the robotic system for the mass production application. Enhanced safety. Robotic welding reduces operator exposure to hazardous conditions like fumes, arc flash, and extreme heat, leading to a safer work environment. For the safety perspective, we can able to use the robot replacement of human. It means if humans can able to work means he use goggles, safety dress, and smoke filters, headset, like various parameters are there. To maintain the human safety, we can replace to the robotic welding system and reduced wastage, waste and cost saving. Precision and consistency in robotic welding minimize error, leading to less material waste and rework. For example, human there is a chance of make a mistake during the welding process. But if it is any mistake is happen, it is very critical to make a rework. If for example during the welding process is just to attach the two material, and we have to welding, once we welded the component, it is converted into the permanent component. If you need to do any changes, you have to again cut the material. During the cutting process, the material get deformation, you have to correct the deformation, then you have to cut the new material, and we have to join another, again need to be rebuilt. So these kind of errors can able to avoid during the welding process in by using the robotic welding. The images explained in the bottom, we can use for high accuracy, and efficiency is more compared than humans, and a high productivity application you can go with this, and workplace safety. So I will just play a YouTube. Just I would like to share how the robot programming can able to use.
Okay, sir. Sir, I think the video is not playing. Sir,
Yeah, yeah, yes.
video is not playing, sir.
Video.
Video is not
Okay,
playing.
okay, okay.
Your screen only is.
Yeah, okay, okay. One second. Yeah, one second. Okay. Just I shared some YouTube videos, maybe some technical errors. We cannot able to see that video. One second. Okay, we'll go with the next session. The methods for programming
Okay.
welding robots. Teach pendants. What are the programming systems are there, and what are the programs are available? We can able to operate the robots. Tech pendants. These and handheld devices. It is a handy devices you are used to manually guide the robot through the desired weld path point by point while recording the movements and welding parameters. This is one technology we can able to operate the robot. Then another is UI based programming system. Modern robotic system, especially core robots. Core robot means the human and robots can able to interactively work, often offer user friendly interfaces with drag and drop functionality and pre-built built actions. The another one is offline programming. Offline program, this method involves using 3D CAD models of the workpiece and the robot to simulate the welding process on a computer, allowing for programming to be done independently. So each and every mechanical engineers should know the 3D model softwares. Once they create the 3D model software, they can able to feed into the OLP programming system. In that 3D model can able to that robotic can able to identify the areas wherever they need to be welding part. So accordingly, they can able to do the welding. So each and everyone should know about the CAD models. Another one is API and scripting for advanced control and automation. Some APIs are used to
Sir, it's not audible. Sir,
uh, sorry, it is disconnected. Now my screen is visible, sir.
yes, sir, your screen is still your screen is not visible, but you are
Okay,
joining.
okay. Yeah, yeah, 1 second, sir. I'll share again my screen. Some technical error.
Okay,
Again, I will
now
go
it's
with.
visible, sir.
Yeah, yeah, okay. So, what are the advantages of the programming? So, just I'm continuing with this. Interpolation defines how the robot moves between programmed points with options like joint, linear, and circular interpolation. Like I explained initially, robotic, we have to operate the robot with our instruction. Humans only need to be give the instruction and setting the programs to operate the system. Sensor integration. The integrating sensors can allow for adaptive welding where the robot adjusts its parameters based on feedback from the welding process. There is a lot of sensors are used in the robot arm. The robot arm through the sensors only can able to sensing the material and welding area where need to be welded. That able to identify that technology. That is the reason they are using the sensors. And simulation is a kind of weld path means wherever we need to be welded. By using CAD models and OLP softwares can help to identify the potential issues and optimize the program before deploying it on the actual robot. So once we feed the CAD models into the robotic softwares and that robotic programming, they can able to identify the wherever the weld path need to be done. Accordingly, the robot can able to start to work. This is the advanced technology in the present and future. I am just before explaining what is the difference of manual welding and robotic welding, how they are using in the industry and what is the application, and that is a future industry. We have to learn through the all these technologies, whatever required. Then now I am going into the slightly in the design part. It means 3D scanner. So how we can able to use the 3D scanning? What are the advantages and applications of 3D scanning? There is a key applications of 3D scanner in mechanical engineering. First stage is first means it is a one type of application. The reverse engineering. The 3D scanning is a crucial for recreating CAD models of existing parts, especially when original design are unavailable or damaged. This allows for efficient production or replacement parts, tooling, and even design improvements. See, if you take automobile industry or wherever the plants, thermal power plants, cement plants, or say chemical industries, wherever it is, there is a mechanical components are there. Once the industry purchase the component and they can use after some time. That equipment can able to damage or they need to reproduce the same with the same parameters with a new component. But if you if as a human if we take a measurement for the precise component, there is a chance to make a mistake. For that technology we have to use the 3D scanner. While using the 3D scanning, that scanning sensors can able to sensing the shape parameters in very high quality of range compared than humans, so that they can able to make the 3D models. It means reverse engineering. The original component is there, you are scanning that original component, that original component is converting into the 3D CAD model. Then you can able to generate the 3D CAD model. Then you will you can later on that 3D model you can create the 2D manufacturing drawings. Through that manufacturing drawings you can manufacture the component after giving into the uh, production sector. So this is the advantages of 3D scanning in the application of reverse engineering. And quality control. So how the 3D scanners are using the for the quality controlling system? By scanning parts and comparing them to CAD models, engineers can quickly identify the deviation and ensure parts meet specification. For example, if you are working in a mass production industry, we are manufacturing, for example, or 200 components per day. 200 components per day in identical component. We cannot able to measure 200 component each and every time by humans. Even though we can able to the random check, it means each 10 parts we can able to measure. Maybe each 50 parts we can able to measure. But there is a chance of error will be there whenever it is required precise component. But if you are using a 3D scanner for the quality purpose, you can scan the complete component in the real time technology. If once the manufacturing is completed, in the next minute you can able to measure the measure the dimensions, whether it is required the as per requirement or not. If it is any error, we can able to identify through the event sensors itself. So that is a technology we can use for 3D scanning. It is very useful for the quality inspection purpose. And prototype and design. 3D scanning enables engineers to create digital prototypes of existing parts or new designs, facilitating rapid prototyping and design iteration. It means, for example, if you are making a 3D printing technology, for that there is a two method is there. You can make a model by using a drafting technology. You can make a model and you can take the feed into the 3D printing programming, and you can deliver the output of after printing. The another one is you can able to compare than creating the part modeling in the software, designing softwares. You can scan within a seconds or within a minute this component able to convert the CAD model. That CAD model you can able to feed into the 3D printing. So for example, somebody can able to do the prototyping system. For that application they can able to use this 3D scanning system. Customization and fit. In situation requiring customized parts such as prosthetics or automotive components, 3D scanning allows for precise measurement and tailoring to specific needs. So again, I'm saying it is a precision. By using the 3D scanning technology, you can precisely able to operate. You can. This is also one of the courses are available in the market. You can learn about the 3D scanner, how to use a 3D scanner, how to convert the 3D scanner into the CAD model, what is the application. You can learn during the your academic session. Inspection. Just before I'm explaining that 3D scanning provides a non-contact method for inspecting complex geometric and surfaces, ensuring dimensional accuracy and identifying the potential defects. It means if for example human can able to measure the component, they have to use the measuring instrument like vernier caliper or measuring tapes or scales, whatever the tools they required. They have to physically touch the material and they have to physically take the measurement. For that you need additional measuring tools. For this kind of 3D scanner, you cannot able to physically touch the material and you cannot require to use the measuring device. The the next one is digital marketing. Digital marketing for it means digital manufacturing. Then you can marketing the product. Digital manufacturing is the use of an integrated computer-based system comprised of simulation, 3D visualization, analytics, and collaboration tools to create a product and manufacturing process definitions simultaneously. Virtual reality. Hope most of the okay. Hope most of the students know about the virtual reality, how we can able to use the computer generated simulation of a three-dimensional image or environment that can be interacted with in a se- seemingly real or physical way by a person using special electronic requirement such as a helmet with screen inside or gloves fitted with sensors. So this virtual reality 3D model only just a 3D model, but you can able to feel the realistic of how the product would be like that before actually before manufacturing. You can able to imagine the product how it would be like that, how the product can able to move, how that product can able to rotate like that kind of things you can able to identify the product before manufacturing also. Then augmented reality, a technology that superimposes a computer generated image on users view of the real world, thus providing a composite view. For example, there is a oil and gas plants are there. Over that, over there is a, if it is any error, people have the any error. The supplier is located in India. That equipment is supplied to the Germany. So in that time, during the supplier receive any complaint about against the product, they cannot able to go immediately. But for this kind of technology, they can able to identify the issue where is the problem and where is the errors and where they need to be rectified from one place to the another place. This is the one advantages of the augmented reality in the future technology. So just overview, I'm come back again. What are the topics which I have been covered? Just I will show it to you one by one. So industrial revolution, I just had a overview review how it is evolving from 18th century to till date. So this is the breakdown what we seen just before and have been explained industry 1.0 and 1 point up to industry 5.0, how it is evolving in the end result, how the human and robot collaboratingly to work together in real future industry, and what are the applications of the automation system using in the cement or power plant in each and every sectors. And I explained just before human intelligence, what is the advantages of the human intelligence. And I explained about the artificial intelligence, what are the advantages and benefits, and how we can able to adopt in the future. And through this welding process, I am explained about the manual welding, then robotic welding. So how the robots are able to work. For example, as a mechanical engineer, we have to operate the robot. What are the needs to be prepared? So nowadays we have to prepare ourselves well in advance before reaching the industry. Their expectation is also that is the way nowadays. So we have to prepare prior completing the course. We have to learn about the additional technology like this away from the syllabus or subject, whatever it is. It's industrial oriented programs. Methods for programming and welding robots. This is a key consideration for programming. Next, I explained about the 3D scanner. 3D scanner is a very essential technology have to adopt in future. So we need to compulsory learn and know about the 3D technology through the academic session. So these basic things I just explained about the virtual reality and augmented reality. Almost I have been actually it is a vast subject that The automation system is a very vast subject. Just I covered for just sharing my knowledge to you to know about the how the future industries are like that, how we have to prepare ourselves, how we have to learn many things away from the syllabus or subject to adopt to the industry. So we have to grow our knowledge through the during college duration. We have to learn from the industrial oriented programs also. That is very important for us. And we are also conducting some kind of design training for the engineering students through the mechanical softwares and design automation training of the 3D model and other industrial manufacturing drawings, organizing the internship program for work real-time projects, supporting engineering projects for the engineering students. We are supporting the internship program what the industries is needed. So accordingly we are giving the opportunities to the students to explore their knowledge, and meantime sharing our knowledge to them to encouraging the students and adopting with the technology. This is our basic things. Yeah, that's it, sir. I completed my presentation actually.
Okay, sir. Thank you, sir. Thank you, sir. Uh,
Yeah,
it was very
thank
useful and informative. We'll make sure that you made us to make an interaction between industry and education institution. So we'll make use of this. You have also explained about how the AI has been implemented in industry and how it has been involved in mechanical engineering also. So it was very useful, and I hope the students also had gained some knowledge about the information which are happening in the engineering part, the 3D sections. Thank you so much, sir. First of all, I
yeah,
like to
thank you, sir.
thank. First of all, I'd like to thank the Almighty God for making this generic talk series to be conducted smoothly. I like to thank the management, VC sir, principal sir, Dean Research sir, and Dean Academic sir, and Department HOD. Ma'am, HOD ma'am, for making this event to for conducting this event a grand success. I also thank all the participants, all the parents, and the various faculty members from other departments, also AI department, ADS department, who made this event a grand success. Thank you, one and all. Thank you. Thank you, sir.
Yeah, thank you, sir.